Hi everybody. I'm going to show you today some things about graphing lines and finding the equations of lines. There are three formulas we'll be using a lot, and you got to be familiar with these formulas. The slope formula, I'd like to show you this. The slope is equal to, and this would be read delta y over delta x. That little triangle is the Greek letter delta. And delta means change, so that's the change in y's over the change in x's. And that's illustrated by the difference in the y's over the difference in the x's. You're familiar with the slope formula. You're also familiar with the slope-intercept form, y equals mx plus b. When we graph lines, we'll use that a lot. But here's a very important part, and you might know about this one too, called the point slope method. The point slope formula, and we're going to use it as a method to find the equations of lines, given by y minus y sub 1. You'll make a substitution here, and we're using this formula. You'll make a substitution for m, which is the slope, and you'll make a substitution for x sub 1. And you'll see lots of things about that in a moment. But just you might want to write down those three formulas, and then we're going to use them as we work through this page. Let me zoom in a little bit, get a look at this. So on the graph at right, and this is the page that goes with the video, on the graph at right, show the graph of line L, which has this equation. And you would say, well, this equation is pretty easy to interpret. The slope is 3 over 2. And the y-intercept is negative 6. So knowing those couple of things, we can graph this line quickly and easily. I'll go down 6 on the y-intercept, on the y-axis to the y-intercept of negative 6, and from there I'll follow the slope, up 3 and over 2. As I think about going up 3 and over 2, that'll be just fine, but if I went up 6 and over 4, that'd be just as good, and that'd take me to this place. And those points are collinear, so we can show that line. And that's what we'll do. Making a nice long line. And since that was line L, we called that one line L, let's put an L beside it. We can keep track of things. So we've got line L in place. But now we have the second equation, line M, and it takes this form. Rather than scribble all over this page, I'm going to work it on a different piece of paper. You might want to do the same thing. I'm going to take the line 3y plus 2x equals 12, and I'm going to put that into its slope-intercept form. To do that, I'm going to make it look like y equals mx plus b. I want this to take the form y equals mx plus b. And that's a really important little skill, but lots of people have a hard time with it. Here's what I think. I'm just going to keep a y alone on the left-hand side. 3y equals negative 2x plus 12. But as I get y alone on the left-hand side, I got to get rid of that multiplication with 3. So I'm going to divide this side by 3 and divide the other side by 3 as well. And then we'll have the equation. And 3y divided by 3 just leaves y equals, and here we find the slope, negative 2/3 x plus, and then 12 divided by 3 giving a y-intercept of 4. So there's my slope-intercept form. I'm going to scribble it on this page. The slope-intercept form should have been y equals negative 2/3 x plus 4. And then it'd be easy to tell somebody the slope negative 2/3 and the y-intercept of 4. And I'm going to show that line, graph it right away. It has a y-intercept of 4, so I'll go up 4 places on the y-axis. And from there I'll follow the slope. It tells me to go down 2 and over 3. And I can do that, go down 2 and over 3. But if I went down 4, I'd go over 6. And I think that would take me to this place. Down 2 over 3 is about like going down 4 and over 6. So I'm going to go through those points, and they should appear collinear. And there's my line. I think that we're going to call this line M. Yep, this one is line M. And you might recognize that those lines are, in fact, perpendicular. Those lines make a right angle right there. Looks perpendicular to me, and in fact it is. And how I knew it had to have been perpendicular is by virtue of the slopes. This one has a slope of 3 over 2. This one has a slope of negative 2 over 3. Since those are what we call negative reciprocals, then I know that those two lines are perpendicular. We're going to work some more. I'm going to graph on the same graph a line N. It's got this equation, and I'm going to take it to another piece of paper and go to work with it. 2y minus 6 equals 3x. And what I'm going to do with it is just take it, make it to match the form y equals mx plus b. Then I can know the slope and the y-intercept. So I have to isolate the y guy on the left-hand side, so it takes this form. I'll start this way. 2y is equal to 3x plus 6. So I bring that negative 6 to the other side. You can think of adding 6 to both sides. Then I'm going to divide through by 2 to isolate the y guy. Divide through by 2 on both sides, which yields y equals 3 over 2x plus 3. So that's my slope-intercept form for the second equation, line n. I'm going to write it right here. Y equals 3 over 2 x plus 3. And if somebody asked me about the slope and the y-intercept, that'd be easy. The slope is 3 over 2, and the y-intercept was 3. I want to show the graph of that line also, on the same graph. With a y-intercept of 3, I'll march up 3 places on the y-axis, go through that point. And from there I should follow the slope, up 3 and over 2. I can go from up here, I can go up 1, 2, 3, and over 1, 2. But you might think about going down 3 and left 2. That would put you on the same line, wouldn't it? So these 3 points ought to appear collinear, and I'm going to show their graph right now. That's my line N. And you're probably thinking to yourself, well, those lines appear parallel, don't they? As a matter of fact, they do, don't they? Line L and line N are parallel. I'm sure they're parallel because line M has a slope of 3 over 2, and line L has a slope of 3 over 2, and line N has a slope of 3 over 2 also. And when lines are parallel, they have equal slopes. In fact, lines are parallel if and only if they have equal slopes. So here it asks me, what relationships must these lines hold? Had a moment to think about that. I have a report that L is perpendicular to line M, and if you look at my graph, you'll agree. Line L is perpendicular to line M, and line L is parallel to line N. But you might be thinking about that. If a line is perpendicular to one of a pair of parallel lines, won't it be perpendicular to the other one? So I'm thinking, yeah, it's true that M and N are also perpendicular. Line M is also perpendicular to line N. That's relationships that these lines would hold. We're going to do some more. Here comes an interesting formula. But first off, for every 2 points, there exists exactly one line. That's a postulate from everybody's geometry class. And given these 2 points, we're going to find the equation of that line. First, it says, show the process as you find the slope between these 2 points. And I'm just going to remind you, man, this is our slope formula. The change in y's over the change in x's. And here we go. Let's march down that path to find the slope of segment AB, or line AB. I'll start with a y-coordinate 2 minus y-coordinate 9. A thing that's important, if I take that y-coordinate first in this quotient, then I must take this x-coordinate first in the same quotient. So that'll be 6 minus negative 8. And here's a really good time to be careful. 2 minus 9 is going to give me a negative 7. And 6 minus a negative 8, that's really the same as 6 plus a positive 8, that's 14. And negative 7 over 14, we ought to call that negative 1 over 2. Yes, you ought to reduce every fraction you get, every chance you get. Now, here's a big deal formula. This guy right there. That's the one I was talking to you about earlier, to being the point slope method for finding the equation of a line. I think I can probably make that fit right here. I'm going to write that formula first. Y minus y sub 1 is equal to m times x minus x sub 1. That's a formula you're going to want to memorize. We're going to make a substitution here for y sub 1, a substitution for m, and a substitution for x sub 1. I could use either one of these 2 points. I might use them both just to show you we'll get the same answer. But first, allow me to use point A first. I'll use this x-coordinate and that y-coordinate in this formula, and I'll use the slope that we found in that formula as well. So here we go. Y minus, and for the y-coordinate of the point I've chosen point A, is 2. And the slope that we're using is a negative 1/2 times x minus the x-coordinate of the point I've chosen, and that's a 6. Now I've got to do a little careful work here. I'm going to multiply that negative 1/2 through the parentheses, and I'm just going to keep this y minus 2 on the left-hand side. Y minus 2 equals, and as I multiply through those parentheses, I'll get a negative 1/2 x, and here I'll have a negative times a negative, therefore a positive, and a half of 6 is just 3. As I seek to put this into its slope-intercept form, I'm going to isolate the y guy on the left-hand side. So I'm going to add 2 to both sides of this equation, and it becomes y equals negative 1/2 x plus 5. So now I'm going to graph that line. But actually, let me kind of play around first. Let's graph these 2 points. Over 6 and up 2. I think that's over 3, 4, 5, 6, and up 2 would be just about there. That should be point A. And point B was left 8. I think that's 8. Let me check that. 4, 5, 6, 7, 8. And down 9, was it? Or up 9. That's going to be right about here. And I'm just getting pretty close. It's not going to be perfect. There's my point B. Now let's graph this line and see if it goes through A and B. I think it'll be pretty close. It has a y-intercept of 5. We can see that that's true. I go up 1, 2, 3, 4, 5. And from there I ought to follow the slope. And the slope tells me to go down 1 and over 2, so I'll try that. Down 1 and over 2, taking it to about that place. And I'll connect up those couple of points and be really pleased if it looks like it goes through A and B, and I'm thinking it does. So that's kind of a big deal, graphing that line and getting it right. Because that's such an important idea, we're going to practice it and do it again. The first thing you ever need, whenever you want to graph a line, the first thing you always need is the slope. So let's find the slope between these 2 points. And I'm going to remind you it's delta y over delta x, meaning the change in y's over the change in x's. Let's start with the y-coordinate. 5 minus the y-coordinate negative 7 over, use that x-coordinate first, you got to use that y-coordinate, use that y-coordinate first, you got to use that x-coordinate first. So this would follow with 4 minus negative 2. And you bear in mind all that arithmetic stuff. 2 minus signs make it a positive, so that's really 5 plus 7. That'll be 12 over 4 minus a negative 2, really 4 plus 2, there's 6. So that slope is just 2 over 1. Yeah, that's the same as 2, but when it's a slope, I like to think of it as a ratio. So I'm thinking the slope is 2 over 1. And you might be thinking, man, that's the negative reciprocal of this slope up here. So these lines are going to be perpendicular. And we'll see that in a minute. I'm sure it's true. Now, I could use either point P or point Q. This time I will use both of them and show you that it works. But I'm going to work with this formula, y minus y sub 1 equals m times x minus x sub 1. This point slope method, that is the ticket that we will use to find equations of lines. We will make a substitution for y there, and for the slope, and for the second coordinate for x, for y sub 1 and x sub 1. And I've chosen this time to use point P. That'll work well. We're going to do it in a minute with point Q and get the same answer. You'll see that this is true. This should be the slope that I'll use. So here goes. Y minus, and y sub 1, that would be the y-coordinate of the point I've chosen. That's 5. And the slope we're using has to be this slope, that's a positive 2, times x minus the x-coordinate of the point we've chosen, that would be 4. Next thing, we got to multiply through those parentheses. Leave this left-hand side as it stands, y minus 5 equals, multiplying through the parentheses, 2x minus 8. Now, if we want to isolate the y guy on the left-hand side, we'll have to add 5 to both sides, and that equation would become y equals 2x minus 3. And I think that's probably the right equation. But I think it would probably be valuable for you to see that I could have done it with this other point as well. Let's just take that walk and see that that's true. I'm going to use the point negative 2, comma, negative 7, and the same slope, the slope of 2 over 1, and see if we don't get the same equation of that line. I'm using that formula, y minus y sub 1 equals m times x minus x sub 1. It's good to get some practice. Let's begin. Y minus, and the y-coordinate of this one is negative 7. And for m, I should use 2 over 1, or just 2 in this case would be okay, times x minus And the x-coordinate is a -2. And there's a little house cleaning to do here. When you got two minus signs on the same number, we're going to call that y plus 7. Same idea there when we got two minus on the signs on the same number. So that's just really going to be 2 times x plus 2. Let's multiply through the parentheses there using the distributive property. But on the left-hand member, we'll keep y plus 7 equals, multiplying through the parentheses, 2x plus, and multiplying there, we'll find a 4. And as we isolate y on the left-hand side, we'll subtract 7 from both sides, and I have y equals 2x minus 3. And that is the equation we found last time. So I'm just showing you that we could have used either point. Let's graph that line right now. And you know that the y-intercept would be -3, so I'll go down 3 places on the y-axis. And from there I ought to follow the slope. And the slope is 2, but we're thinking of that as 2 over 1. So I could go up 2 and over 1, or I could go up 4 and over 2, and those points should appear collinear. Let's see a look at that, get a look at that line. Something about like that. And you're thinking, those lines look perpendicular? And in fact, should they be perpendicular? And the answer is yes, they should, because this one had a slope of -1/2. What would be the negative reciprocal of a -1/2? That's a positive 2 over 1. So yep, those lines had to be perpendicular. Let's turn a page and see what else we can do. This begins with another postulate, something that people just think is so obvious it must be true. Through a point not on a line, there exists exactly one parallel line. We're going to start with this equation. We're going to put that equation to its slope-intercept form. I probably have enough room to do that right here. I'll leave the 3y on the left-hand side and bring everything else to the other side. And it would become 3y equals -4x. When I bring that -24 to the other side, it becomes a positive 24. And then I got to divide through by 3 on both sides. So that's what I'll do. Just divide this other side by 3 also. And I'll get the equation y equals -4/3 x plus 24 divided by 3 plus 8. And there's the equation I care about. That's the one that I can graph it from. And it asked me to show the graph of line L. So I will. A y-intercept of 8, so I'll march up 8 places on the y-axis. 5, 6, 7, 8. I think it's there. From there I should follow the slope, which tells me to go down 4 and over 3. If I go down 4 and over 3, that'd take me to about there. But if I went down 8, I'd have to go over 6. That's the same as down 4 and over 3, huh? And I think that would take me to this place right there, 3, 4, 5, 6. And I hope that those points appear collinear, and we could get a look at that line. There's my original line. That's line L in this case. We're going to show, we've shown line L. Now we're going to show line M, which is parallel to line L. I'd make this little note right away. The slope, using M for slope, of a parallel. What should be the slope of a line parallel to this one? And what I hope you remember is, when lines are parallel, they have equal slopes. The slope of this one is a -4/3, so the slope of any parallel line would also be -4/3. And it tells me it's got to go through this point P at -6, 3. Just for grins, I'm going to go ahead and graph that point first. Left 3, 4, 5, 6, and up 1, 2, 3. There's point P. So in a minute, when I get this graph going, it should go through that point and it should appear parallel to L. Let's see if we can't make that happen. It says, show me the process as you find the equation of the line M that's going to be parallel to this line, and it goes to this point. Whenever I write the equation of a line, find the equation of a line, I'm going to use that same formula, y minus y sub 1 equals m times x minus x sub 1. And we will make substitutions in this position, and that position. Carefully, let's walk through there. Y minus. And in the place of y sub 1, the y coordinate of the point I want to go through. That's 3. In the place of m, the slope, we should use the slope of the line that we expect to have, since we're parallel to this one using that -4/3 slope. Times x minus -6. I'm going to go ahead and call that x plus 6, may I? Because when it's x minus a -6, that's going to be x plus 6. Just save a step there. Next I got to multiply through those parentheses, and I have y minus 3 equals negative 4/3 x. Now I got to figure out what's 4/3 of 6. That's really a pretty simple thing to do. I'll do it right here. 4/3 of 6 over 1. 4 times 6 is 24. 3 times 1 is just 3. Yep, that's going to be 8. 4/3 of 6 is just 8. But bear in mind here, this was a negative 4/3 of 6. Therefore, it's got to be a negative 8. I want to isolate the y guy on the left-hand side. To do that, I got to add 3 to both sides of this equation. And here will come the finished answer. Y is equal to negative 4/3 x. And if I add 3 to that negative 8, that's going to give me a negative 5. So I think that's the equation of that line. Let's take a minute and graph it. It has a y-intercept of negative 5, so I march down 5 places on the y-axis, right to there. And from there I should follow the slope. The slope tells me go down 4 and over 3, and I can do that. Down 1, 2, 3, 4, over 1, 2, 3. But I could also go up 1, 2, 3, 4, and left 1, 2, 3. And those points, this one, and that one, should appear collinear. And it looks like it's also going to go through point P, doesn't it? So I'm kind of pleased about that. I think things are working as they should. There's that line. How do we call it? Line M. And you're thinking like I'm thinking. They appear parallel to each other, huh? So I ought to put a couple arrowheads on them. There we have the equation of those two lines. One more exercise for us to look at together, please. And read this postulate. Through a point, not on a line, there exists exactly one perpendicular. So I guess we're going to be looking at a perpendicular this time. Line L has this equation. Put this equation into its slope-intercept form and show the graph of line L. So we have to manipulate this guy first. I think I've got enough space to work that right here. 5y plus 2x equals 20. And you're bearing in mind that he wants to make this look like y equals mx plus b. When we can make it that way, we'll know the slope, we'll know the y-intercept. I have to first bring that 2x to the other side. This would become 5y equals negative 2x plus 20. But if we want to solve this for y, get y by itself, we'll have to divide through by 5. I'm trying to do that as quickly and easily as possible. I'm dividing everybody by 5. That'd be 5y divided by 5 would just be 1y. And negative 2 divided by 5, we'll leave that as just negative 2/5 x. And that 20 divided by 5 leaves me with a 4 right there. So I'm thinking, there's the equation of this line. There's the equation of our line L that has these couple of points. Here's something that you might have thought to have also. This is called the standard form. And here's an interesting thing. If you let x be 0, if x were 0, then this would be 0, and 5y would be equal to 20. That'd force y to be 4, wouldn't it? Another thought could be, this won't always work so smoothly, but it does in this case. This time, what if I let x be 0? What would y have to be? Oh, I already did that. What if I let y be 0? What would x have to be? If I let y be 0, x would have to be 10, wouldn't it? Because 2 times 10 is equal to 20. So when I graph this thing, these 2 points should be on this line. Let's take a look and see if that works that way. A y-intercept of 4 for this line. I'll march up 4 places on the y-axis. From there I'll follow the slope, down 2 and over 5. I can think about going down 2 and over 5, but I could also go down 2 and over 10. Down 2 and over 5, excuse me, down 4 and over 10 is what I should have said. And that would show a line that looks about like this one. And lo and behold, it does have those 2 points on it, doesn't it? Here's 0, 4 and 10, 0. So, yep, those 2 points do fit on that graph pretty well, don't they? This time, though, we're going to find the equation of a line M that's perpendicular to this line L. Let me bear in mind that this one was L. To be perpendicular, it asks me what must be the slope of this line M that is, in fact, perpendicular. A nice note to make would be the slope of a perpendicular should be the negative reciprocal of this slope. This line L, had slope of negative 2/5. The negative reciprocal of this negative 2/5 would be a positive 5 over 2. With that slope, we're going to find the equation of a line that's perpendicular to the original. And this one asks me to go through point Q, which is at negative 4, 3. I'll bring that here. Negative 4, 3 is the point I want to work. Ooh, that's a negative 4, negative 3. Pardon me. Negative 4, negative 3. And with slope equal to 5 over 2. Let's go to that tool that works to find the equation of any line anytime. That's y minus y sub 1 equals m times x minus x sub 1. Pretty soon, when you get good at this, you won't even have to write that formula down. You can just write the equation of the line, and it's really a nice way to go. We're going to make a substitution here, and here, and here. Here we'll put in the y-coordinate of the point we want to go through. Here we'll put in the slope, and here we're going to put in the x-coordinate. So that would look like y minus negative 3 equals, and for that slope, that's a 5 over 2 times x minus the x-coordinate, negative 4. Yeah, we ought to fix those double minus signs, and that's a step we can get through a little quicker later too, but right now we're just figuring this out. So that would be y plus 3 equals 5 halves x, 5 over 2x. That's a plus sign right there, huh? So I'm thinking of that as being a positive 4. So I got to go 5 times 4, that's 20, divided by 2, and that'll be a positive 10. Now, let's isolate that y guy on the left-hand side. So I got to subtract 3 from both sides, and it would become y equals 5 over 2x, subtracting 3 from both sides, plus 7. I think this ought to be the line. But let me play around for a second. This line should go through this point, negative 4, negative 3. Let me put that in place. Left 1, 2, 3, 4, down 1, 2, 3, somewhere about there. I'm going to call that point Q. Now let's graph this line and see if it goes through that point and appears perpendicular to line L. And if it does, I'll be happy and glad we got it right. So if we're going to graph this line, what should we think of first? Yep, the y-intercept. So we have to march up 7 places on the y-axis. 1, 2, 3, 4, 5, 6, 7, right there. And from there, I got to follow the slope. The slope tells me to go up 5 and over 2. And I could try to go up 5 and over 2, but I could also go down 1, 2, 3, 4, 5, and left 2. And I think that would take me to a point right about there. I'm going to connect those points up and see if it looks like it goes through Q and see if it's perpendicular to the original. And it's not perfect, but it's pretty darn close, isn't it? I'm thinking that those lines appear perpendicular right there. If I slid a piece of paper, you'd say, yeah, that does look like a right angle right there. So that's pretty close. And it does go through the point negative 4, negative 3. So I think we got that right. Now, I have an assignment for you to do the same kind of stuff. I appreciate you doing it. Thank you, guys.